20 team shirts cost $300. How much does each shirt cost? And show your thinking. So another way of saying this would be to say that it's $300 for 20 shirts. So how much does each shirt cost? We've really got a simple division question at that point. 300 divided by 20, which we can simplify just by scratching out those zeros, to be 300 divided by 2, which is 15. So that's $15 per shirt. So that gives us the unit cost. Another way of thinking about that would be if we'd used our algebra method, we'd have said 300 over 20 is equal to some price x over 1. And you can see it very simply then that x becomes 1 times 300 divided by 20, which is really the same thing. Which is the better buy each time? Explain your thinking for one or two of your answers. Okay, we'll start off with item A here. 7 items for $15 or 10 items for $20. Which one is the better price? So the first thing I look at is I see this 10 items for $20. I know that those numbers give me easy math. So I've got $20 for 10 items. That tells me that it's $2 per item. The second part is 7 items for $15. So without having to do the math specifically, I can think about if I had $2 times 7, that would only be $14. So I know that in this case, it's telling me I've got 15. So in order to get from 7 up to 15, I'm going to have to multiply by something greater than 2. And if I did the math exactly, 15 divided by 7 would come out to $2.14. So in this case, the 10 items for $20 is a better deal than 7 items for $15. Part B, 800 grams for $12. Part B, 800 grams for $12 or 500 grams for $6. Which is the better deal? So if it costs me $12 for 800 grams, how does that compare to $6 for 500 grams? If I start with the 12 over 800, I could reduce that down by dividing both the top and the bottom by 4. I can end up with 3 over 200. And now that's fairly easy to simplify further. If I divide both sides by 2 again, I get $1.50 per 100 grams. Now for the $6 and 500 grams, there's no quick easy math to do for that one like we had for the 12 over 800. So I'm going to use the algebra that we were used in one of our earlier units, and we're going to say that $6 per 500 grams is the same as some value of x for 100 grams. Solving for x, we know that x is then going to be multiplying both sides by 100 times the 6 over 500. The zeros cancel out, so we get 6 divided by 5, which is 1 1/5, or 1.2, which if we convert to currency is $1.20. So in this case, we can see that the $6 for 500 grams is a better deal than the $12 for 800 grams, because it has a price of $1.50 per 100 grams, whereas we found there's only $1.20 per 100 grams here. Part C, 15 items for $48 compared to 20 items for $60. Again, I'll look for some easy math when I can. 20 over 60, I can cancel out the zeros, end up with 2 over 6, which is very easy to say 1/3. So you get 1 item for $3. Now looking at the 15 items for $48, if I think back here, first of all, say, well, is it going to be greater or less than $3? Well, if it was $3 per item, we'd have $3 times 15 items. That would be $45. But we've actually got $48 here. So that means the price has to be greater than the $3. Using our algebra again, we've got 15 over 48 is equal to 1 over some unknown value. Remember, we can do the reciprocal of both fractions and have 48 over 15 is equal to x over 1. So x is equal to 48 over 15, which if we do on our calculator is $3.20. So we can see that 20 items for $60 is a better deal than 15 items for $48. Because here we're only paying $3 per unit, whereas here it's $3.20 per unit. Finally, Part D says we've either got 4 items for $75 or 2 items for $40. So 4 for 75 or 2 for 40. Again, we look for some easy math. 2 for 40 means that's the same as 1 for 20. We just have to divide both the top and bottom by 2. If that was the case, here we'd say, well, if they were the same price, then 4 times 20 would tell us the total, and in this case, that gives us a total of 80. Clearly, 80 is more than 75, so the 4 items for $75 is a better deal than 2 items for $40. If we actually did the math and divided the $75 into 4, so we're dividing both the top and the bottom of there by 4, we end up with 1 over $18.75. So it's $18.75 if you're getting 4 for 75. And we can check that just by saying 4 times $18.75. And if we do that on our calculator, we of course get back to $75. Which has the same unit price as 7 for $30? In order to solve this, I first want to figure out what is the unit price that we're dealing with here. So if we pay $30 for 7 units, that's the same as saying x dollars for 1 unit. So x is equal to 30 divided by 7. So x is equal to $4.29 if we do that on our calculator. Now we'll need to look at each of these, A, B, C, and D, and figure out which one has the same value. $50 for 15 is equal to $3.33. $10 for 2. Pretty easily we can see if we're dividing both top and bottom by 2, we get $5 for 1. $17.14 divided by 4 is $4.29. And just check the last one, $25.50 divided by 6 is $4.25. So the answer is C, is the same value. Explain why you might figure out the price of 3 items rather than 1 to compare the price of 6 for $32 in one store and a price of 9 for $50 in another. So they're telling us it's $32 for 6 items, and we're comparing that to $50 per 9 items. So we can see that both of these, the 6 and the 9, are multiples of 3. So $32 for 6 would be the same as saying $16 for 3, because we divided both the top and the bottom by 2. In the case of $50 divided by 9, we'd need to divide by 3 if we're going to end up with 3 on the bottom. So we'd end up with 50 divided by 3 on the top, and that's not necessarily easy math to do. However, once I've figured out that this is $16 for 3, I know now to get the price for 9, I just have to multiply that by 3. So I'm doing 3 times 16, and that's going to give me this price for 9. So that would be 3 times 16 is 48. So $48 for 9. But over here, we've got $50 for 9. So clearly, the 6 for $32 is less expensive. You could have got to the same place by thinking about $32 per 6 and looking at the relationship between 6 and 9. How are we going to find this 48 basically? So to get from 6 to 9, we multiply by 1.5. Right? Because if you think about it, 1 times 6 is 6. And to get from 6 up to 9, you have to add 3. But 3 is half of 6. Right? That's a half. So 1.5 times 6 is equal to 9. That deals with the bottom. So now if we want to maintain the same proportionality, we have to multiply the top times 1.5. 1 times 32 is 32. Half of 32 is 16. 16 plus 32 is 48.